Good afternoon, everybody, and welcome to We All Use Math Every Day. My guest today is Matt Benintendo. Matt is a criminalist with the New York City Office of the Chief Medical Examiner. He's worked with OCMA for 17 years. He's responsible for examining evidence from criminal investigations, looking for biological material, running DNA tests to identify the source of that material as well. In his work, he makes use of math and science every day, and particularly statistics. So, Matt, welcome.
Good afternoon, everybody.
So, it's good to have you here. Matt, in your description there, it mentioned that you were a criminalist. Does that make you a sort of scientist or what?
Yes, I'm considered a scientist. A criminalist is a scientist that examines physical evidence from criminal investigations, looking for trace amounts of material, let it be biological or physical, like paint or hairs and fibers, to do further analysis on them. So yes, a criminalist is a scientist.
Okay. All right. Well, let's take this back a little bit. We have quite a few people who are watching this that'll be students in high school right now. So I want you to think back to when you were a student in high school. How did you get interested in science and mathematics at that point?
Well, I actually got interested in science and math before high school, when I was in elementary school. It was the two classes that always came more natural to me. I always found them more interesting. I did extra study in them. It also helps when you have fun teachers that are teaching the material, so you grasp it a little bit easier. I more concentrated on my math and science classes than, let's say, my English or my history or social studies classes. So I kind of got interested in science and math in elementary school. And then more particularly, I kind of got interested in biology because of some of the traits of my father. For example, he was a police canine trainer for the city of New York. And we always had a dog around. So I always got interested in animals and dogs. So biology was a heavy influence on me growing up when it comes to math and science.
Okay. So you went through high school then at that point, and some of the people in our audience are seniors now and are still kind of seeking out the direction they may go. Coming out of school and you going into college, what was your career goal and field of study then?
Well, because math and science came more natural to me and I had a heavy interest in it, I was interested in veterinarian medicine. Again, it goes back to my father being a lead trainer for the NYPD here in the city of New York, training police canine dogs. And I remember always going to the vet with him when we had to do service on the dogs. And then when his police dog died, we got into raising and breeding Jack Russell Terriers here in New York City. So that was interesting because we would actually administer our own shots to the dogs. I would always go to the veterinarian when they needed some type of service. So I was always interested in that type of biology, especially with animals. So that's kind of what I chose as a career goal as I transitioned from high school into college at the State University of New York at Stony Brook. I went for their general biology program.
Okay. So you got into animals, you were interested in veterinary science. How did you transition then from veterinary science to what we just described, forensic science?
Well, going through college, you're going to get exposed to a lot of different variety of science and math classes. And you'll have other opportunities. And while I was taking my coursework, I was very interested in the molecular biology lab work that I was doing. Additionally, I was given the opportunity to be an undergraduate teaching assistant on a couple of the molecular biology lab classes that I had taken as a lower level college student when I was a senior. And I really enjoyed the teaching that I was doing as well. So when I graduated from university, I was kind of stuck. Now I'm interested in three things: veterinary medicine, teaching, as well as molecular biology lab work. And I knew I was going to take a year off before jumping into veterinarian school over in England if I made that transition. So I kind of let it simmer for a year while I got a basic office job at my local YMCA. And it just manifested where I ended up, I have an identical twin brother. His name is Chris, and he was always interested in the field of forensics. That was always his thing. My thing was always biology. And he had gotten hired at the crime lab here in New York City. And every month they would go bowling, the criminalists there, the scientists. And I had gotten invited as a friend to go bowling with them, and we struck up a conversation. And they were asking me about my background, and they made the offer of, hey, they're hiring people at the medical examiners looking for somebody like you, a background in science and math with no experience. The following day, I submitted my resume. I got an interview the end of that week, and they hired me the week after, and I've been there for 17 years. And I've had no regrets not choosing my original career path. I definitely love what I do, using that molecular biology that I learned in school here to help the criminal justice system here in New York City. I'm also a trainer in my agency, so I also have a little bit of that teaching that I can do now as a part of being a senior criminalist that I am.
Okay. Well, as you made the shift into, and you started out as a forensic scientist, what kind of work did you start out having to do? What were you responsible to do as entry-level forensic scientist?
So entry level is more of being a lab tech. You're not really using your mind very much, like trying to manage a case or come up with a plan of how to examine an item of evidence. You're pretty much just a biological robot. So some of the things that I learned in college are traits that you would use in any molecular biology laboratory. Good note taking, right? Another example would be pipetting, which is a device that we use to transfer fluid from one vessel to another. So that's a basic trait. Microscopy. We use microscopy in the laboratory at entry level. I was responsible for screening slides to see if spermatozoa were present on the slide as a confirmatory test to determine whether a sample has sperm in regards to a sexual assault case. So there are little traits here and there as just going through your basic biology program that I jumped with when I got hired at the ME's office.
Matt, so many students have stories about when they start studying for something. They're really excited about that one area, and then in the end, kind of similar to you, they end up doing a slightly different kind of field of work. So you went from veterinary science to forensic scientist. What kind of learning and skills, what concepts and skills did you study when you were pursuing veterinary science that ended up that you found out started preparing you for what you do now in forensic science?
Well, when you choose a general biology coursework that I did, it's very diversified. So I was taking, cell biology, biochemistry, molecular biology, in addition to anatomy and physiology that you would take if you were going into veterinary medicine or physician assistant or an MD. So anytime I had the opportunity, I would take a lab class. And part of that was because I found them the most interesting. It's one thing to learn just by reading in a book. It's another thing learning by actually performing experiments in a lab. I always found that it was easier and more fun and more engaging. And I hold on to that information better by doing it in a laboratory. So I always tried to jump on any type of lab course that I could. And that set me up for, even if I didn't do like a criminalist in a forensic lab, that core work could be used in a private pharmaceutical laboratory. So by doing a general biology program made me pretty diverse coming out of it, where I could have easily springboard into teaching or into vet school or medical school, or to become a criminalist as a forensic scientist, or to work in a private research laboratory for cancer research, or a screening lab like Quest Diagnostic. So just by having a diversified program in the state university that I went to really set me up so that even if I didn't choose that original career path that I went in for, it gave me options on the back end.
Okay. Were there other skills that you ended up picking up along the way in that beginning work that you did? What were some of the most important things that you learned skill-wise that you find yourself doing now? Maybe even things that you don't learn in a class in college.
Got it. One thing is ethics, especially in the field that I work in. It's always important to have good ethics. If you make a mistake, any mistake can be rectified. It can be fixed, as opposed to reporting out incorrect results. And there's ramifications. In my field, I could put an innocent person in jail or let somebody off who should be in jail out on the streets. One key thing is just documentation, proper and clear, concise documentation as you're performing work. I don't have the best of handwriting, so it's something that I've had to like learn that if you write clearly, a lot of times I need to look back on a case a year from now that I did the original testing on that's going to court a year, 2 years after the fact, and I need to be able to understand how I performed that testing, why I did certain things. So it's always clear to have good documentation. Going through college, it's just multitasking, coming up with a mission or a plan of action in order to accomplish a series of goals. And what I do, it's nonstop. It's a revolving door. Just at the end of the day, the case is not over. There's 10 more coming through the door. So it's just a matter of trying to prioritize that. Okay, maybe cases that are against people like homicides and sexual assaults, I need to prioritize them more than cases against, like a burglary or a grand larceny where someone breaks into a car and steals something. So it's understanding that prioritization with what you have. Yeah, those are some of the tasks.
Okay. I know one thing that some of the students who talked to me said they're really interested in hearing more about. Maybe isn't this part we've talked about so far, but what it actually is like to be a forensic scientist. What do you actually do? Like they see a teacher and they feel like they have a pretty good idea of what a teacher does from day to day or what our daily life might be like. So give us a little peek into your life as a forensic scientist.
All right. So it's not as glorified as what you would see on TV and movies like CSI and whatnot, where it's very dim lighting and, it's a lot of repetitiveness and a lot of following pretty much recipes in a cookbook. We call them standard operating procedures. So when I go to work, I wear in business casual clothes. I go into an office. I have a desk where I do my casework, typing up reports and whatnot. But that's towards the tail end. It actually starts in the laboratory. So I go in, I get gowned up in personal protective equipment, kind of what you see in a hospital or medical center. I wear a lab coat. I wear a face mask, a face shield. I wear 2 sets of gloves, sometimes a hair bouffant if you have hair. I don't have that problem nowadays. But so I get gowned up in personal protective equipment. And one of the reasons is I want to protect the evidence from me. I'm made of cells. I do DNA testing. I don't want to contaminate what I'm working on. But on the flip side, I'm dealing with biological specimens and material. Sometimes these are homicides or samples from decedents. I don't know what they died of. I don't know if they have any bloodborne pathogens and whatnot. So it's to help protect me as well. Once I get gowned up in a vestibule, a little room just off the laboratory, then I step foot in the laboratory, and the first thing I want to do is I sign out a case. I go to a secure storage facility. A person is responsible for me to sign a log called the chain of custody for just to maintain the integrity of that evidence. It comes to me. It's usually in a brown paper bag. I'll go ahead and I'll review the paper bag to make sure that this is the correct item for the case that I selected, to make sure I'm not doing any type of switching. I go to a counter. I go ahead, I open up that bag, and I do an inventory. Let's say this particular case is a a burglary of a home and somebody left a mask behind, and the item of evidence is a mask, a ski mask. I'm going to go ahead, I'm going to document what I have in front of me, what color it is, what size it is, does it have a tag, what is it made out of? I'll take a photograph of it. And then I will think about how will I sample this type of evidence for the question that's being asked. In this particular case, this mask is not the homeowner's. It was left behind by a potential perpetrator. So the question is, who wore the mask? So I will go ahead and I will use a razor blade and I will scrape the fabric of the mask to collect any type of cells that were contained in the intertwine of the fabric, as if you were putting on a mask and wearing it, that would be contained. Every day, our cells are constantly shedding themselves and being regenerated with new cells, replaced by new cells. So those cells get caught up in the fabric that we wear. So I will scrape the fabric, put it in a test tube, that lint, which will contain cells, and then I will go to the next part of the procedure. And the next part of the procedure is where we remove DNA from the cell. It's done at a separate bench top. It's in a vessel called a hood, which is a protected kind of glassed-in box where your hands go in. And it's to protect, this way I'm not breathing over the evidence. It's to protect the evidence from me. And I add a series of chemicals. Typically it's water, osmotic pressure. Water will go into the cell, make it swell and burst, and it will release the cell from the DNA. It will release the DNA from the cell. I then will go ahead and determine how much DNA is present. That's another step along this assembly line process that we're following. That we started with evidence exam, then we're doing extraction, then we're going to do how much DNA is present in the cell. There's a minimum amount of DNA that is needed in order to generate a DNA profile, which is a string of numbers that we use to compare to different individuals to help determine whether that person is the source of that DNA or is not the source of that DNA. In order for us to reliably get that string of numbers, we need to know how much of DNA we have. If it's too little, I'm not going to be able to get that. I'm not going to waste my expensive chemicals and time to do further testing. If there is enough, I will go ahead and I will do DNA testing on that DNA. And the DNA is a very long molecule. I don't read the entire length of it. It's sort of like reading, the entire novel of Moby Dick, which is 1,000 pages. If I gave you that book, do you have to read the whole book in order to identify that book is Moby Dick? No, you don't. You could just pick a few chapters, a few pages and chapters to read them to identify that is that title of that book. We do the same thing with DNA. Once I develop that profile, it's a string of numbers. I put it in a chart fashion, and I compare it with DNA of known individuals like you, Mr. D, or myself, to determine whether that unknown profile originated from you or originated from me. And then I write up a report, and then I go ahead and I testify as an expert witness in a court of law, explaining the significance, what was tested, why it was tested, and the significance of that testing to a jury. So that's what I do in a day-to-day basis. And on top of that, because I'm a senior criminalist, I'm responsible for supervising lower-level criminalists as they perform that assembly line process, as well as mentoring them to advance their career in the field of DNA testing and criminalists.
Okay. When you're testifying as an expert witness, I'm wondering if there's times that people can address or maybe point out that there might be imperfections or something in your DNA gathering or that sort of thing. We hear stories sometimes, that sort of thing. Is it easy to do what you do as far as identifying somebody by their DNA that you find at a crime scene, let's say?
Remember, it is science. So every experiment that we run could, in theory, fail. That's why we have positive controls and negative controls. And that's why we have quality control measures throughout that entire assembly line process to ensure that the quality, that DNA result, is true and accurate at the end. Let it be an unknown specimen from, let's say, that ski mask, or a known specimen like an oral swab, like a Q-tip used to swab the inside of the cheek from, let's say, you or me. The testing itself is not very difficult. Sometimes it's a little time consuming. If anything, it's repetitive. So sometimes it could get maybe a little bit boring at times because you're just moving, especially if you're working in the lab and you're moving just colorless liquid from one tube to another, and you don't see that end product, that profile or that report, or you're engaging with the jury to explain the significance of why you tested something and what the results mean. It could get a little bit tedious, but I wouldn't consider it hard. Sometimes, testifying could be difficult, and the difficulty just becomes with the stress of public speaking, and the stress involved with gamemanship between lawyers. Again, each of them have their own agenda, and as a scientist, we stay neutral. I'm not there for either one of them. I'm there for the jury to answer any and all questions that can be asked of me, let it be from the defense, the prosecutor, or even the judge.
Okay. Matt, actually, we have a question coming from the audience that this seems perfect timing to bring this up. So a student from DV, Gabby Courtwright, asked this question. Do you ever get bored of your job?
Me personally, no. And the reason is I've been there for so long, every year or two, the technology is constantly changing. So even though I'm done, I've been done with school, I'm never done learning. Okay. So because I have 8 hours of continuing education that I have to keep studying to keep myself abreast with the emerging technologies, and the technology that I started with 17 years ago is not the same technology that I use today. So it's just like learning new software, or the new version of a video game that comes out, right? You might be bored with the old video game, but the new one has new technology, new duties and responsibilities, new goals and objectives. So that's what keeps it fresh. So every couple years, the technology changes, my duties change. I started at a lower level criminalist with maybe 4 or 5 duties, and I've gone up from a lab tech to a criminalist 1, 2, 3, and 4. And I've added more duties as I've gone up, and that has kept it fresh and exciting for me. And every case is different. No 2 cases are the same. If I'm doing DNA testing on a ski mask, for one case, it might have challenges involved in a different case. So that keeps it fresh and exciting as well.
Are there skills that you had to pick up since then? We were just talking about how I had to pick up some significant skills switching over to this kind of teaching, but what kind of skills along the way, maybe that you haven't mentioned yet, have you had to pick up since you started as a forensic scientist now to where you are now?
So when I started at a school, I had no problem with lab tech doing the actual experiments in the laboratory. My school, my bio program was perfect for that. But one of the most challenging things for me is public speaking. When I was growing up, I was always the super shy kid. Part of it was I was the youngest in my class. I was the smallest in my class. I never really had my voice growing up. I would be the last to raise my hand in class, even though I knew the answer. I always did my best to try to be in the shadows and not really public speak. And that kind of hurt me in this field initially. Going through college, you had some opportunity to do public speaking, to do presentations in school, but a lot of it was group presentations. And I always tried to take the smallest role, or maybe I'd set up the PowerPoint, but other people would present for it. And looking back on it now, I wish I would have kind of engaged more. But like I said, I was that super shy kid, and part of me still is that shyness does come out. But in the laboratory, we have this joke, I'm a lab rat, right? I enjoy dealing with the evidence, dealing with the lab, and maybe not so much, engaging with the customer, right? Dealing with police that are submitting evidence, or the defense lawyers, or the prosecutors, or even the jury. So that's something that I had to learn. If I didn't learn it, I would have been stuck all the way down at a criminalist level 1. And sure, my job probably would have gotten boring because I wouldn't have been able to advance, because at higher level criminalists, that's one of your key responsibilities, is to have that customer engagement. that ability to testify, to present. So it's something that I've had to work on. And there was several years, 5 years, where I was doing DNA testing on unidentified human remains. In those cases, you rarely ever go to court. And even though I built up that skill set prior to that 5 years, I was worried about losing that skill set, taking a step back because I wasn't actively using it.
Yeah.
So for those 5 years, I would volunteer, believe it or not, I would volunteer to testify on other people's cases, at least a few a year, to maintain my proficiency in that skill, because I worked really, really hard my first few years as a criminalist to gain that confidence to do that public speaking, to testify in a court of law, that I didn't want to lose it. And what's so funny now is I've testified over 120 times in a court of law as an expert witness, which is very high. When it comes, if you look at the list of people and who has the most testimonies, I'm right there in the top 3.
Wow.
And if you would have asked me that when I first started 17 years ago, I would have told you no way that would have ever happened.
Wow.
And so that was something that I had to work on. And if I can work on a skill set that, maybe I was lackadaisical in the beginning, anybody can. So just because you don't have the full skill set for what you're applying to, there's opportunity to learn as you're doing in that field.
Okay, great. We have another question from our audience. So this one showing up now is Michaela Courtwright, and she asks, what would happen if evidence were to get contaminated or mishandled?
So I can only speak, when it comes to contamination, it just means that the evidence has, in my case, a DNA profile on it that maybe wasn't there during the commission of the crime, or right after the commission of the alleged crime is the better way of saying it. For me, a contamination event that I would worry about is something in the laboratory. Does it happen? Yes, it does, right? We're all human. We can make mistakes. That's why we have controls. We have witnessing steps. So if I'm performing a certain step, Mr. D might be witnessing me as I perform that procedure as a quality control. At the end, when we evaluate our DNA profiles, we use some of our science, our logic, when we evaluate that, because if I'm doing DNA testing on, let's say, a known specimen for Mr. D, who's a male, it should yield a male profile, and it yields a female profile, right? I would want to ask questions. I would have to investigate further. Okay, let's retest Mr. D's profile and see, do we get duplicate results? Right? If we get duplicate results, then we know, okay, there's something. Maybe it was the sampling. Maybe it was a sample mix-up. Or maybe Mr. D genetically shows up as a female profile instead of a male, because maybe he has some genetic quirk in his DNA that the sample that I test for, that location that I use to help determine whether it comes from a male, a genetic male, or a genetic female, is funky. It's what we call a mutation at that location, and it prevents me from getting the full result at that location. Sometimes mishandling is usually done by the collection of the evidence by the submitting agency. And for me, it's the NYPD. Sometimes it happens. They put the wrong label on a bag. Again, it's not the biggest end-all thing in the world. We just use logic as scientists and be like, wait, this isn't making sense. Let's go ahead and take a look. Or let's say the person who's collecting the evidence, the NYPD officer, the same profile is showing up on a multitude of cases, a homicide case, a sexual assault case, a grand larceny case. And it's like, usually those aren't connected. So we'll go back to see, okay, who collected this evidence? Maybe they're not wearing their personal protective equipment. Maybe they are, and they're just sweating a lot. Maybe it's the summer and they've left their DNA on evidence. We'll see that link before we report that result out to the public, because ultimately we're looking for the alleged perpetrator. So sometimes a contamination event is usually the person who's handling the evidence, either collecting it, examining it, and testing it. Rarely ever do you have a sample switch of two unknown samples showing up in the same case. Again, we have safeguards. You only have one case working at a time. You only have one item of evidence at a time. We clean our utensils. My gloves, my PPE get changed out and thrown in the garbage, and I put fresh ones on when I move into a new case. So events do happen. They're very, very low considering the tens of thousands of items of evidence that I examine in a year and the tens of thousands of cases that we test per year. The amount of contamination or mishandling is very, very small. It's just, unfortunately, when it does happen, it is a big deal because it could mean that we're linking a perpetrator to a second case when there shouldn't be that link. So we take them very seriously.
Okay. Well, in your work as an expert witness, I asked this question because I know the last couple questions got asked by students or from AP statistics students. And you had mentioned in our past conversations something called a likelihood ratio. And for our AP statistics students, people who have taken that class before, they're well acquainted with this thing called the p-value, which gets a lot of attention and sometimes a little bit of controversy among the statistics community about how important is it and just how difficult it can be to explain to the average everyday Joe what we mean by a p-value. And so what I'd like to have you talk about is what's this thing. Let's get into the math of what is a likelihood ratio and how would that figure into your discussion if you're actually on the stand talking to a jury that probably most of them don't have a statistical background.
Well, you hit the nail on the head right there. So the hardest part of testifying or even statistics in what I do is remembering to explain it to someone who's never taken a statistics class, right? So we don't use a lot of the scientific jargon that, let's say, you and I would if we were in your classroom at Delaware Valley. We would never use certain terminology, or if we did, we would have to define it or find a way, an analogy for them to use to try to comprehend it. So one of the things that we use statistics as a quantitative weight when we do our comparisons. Sure, we could say, okay, the DNA profile that was from the unknown sample matches the DNA profile of the known individual of Mr. D, meaning those string of numbers are the same. It matches. So that's great, but could we add a quantitative value to that to supply some weight, right? So one of the ways that we do that is to do a likelihood ratio to pretty much compare two conditional probabilities, right? And it's pretty much two competing scenarios, and we're using the likelihood ratio to determine which of those two is more likely to occur. So it's tough because when we present it to the jury, the likelihood value doesn't have a number. It isn't like people or meters or feet or grams. It doesn't have a unit. So sometimes it's tough relay or the jurors having an understanding of that. So ultimately, when we describe a likelihood ratio, it is a well-known statistical evaluation of data that is used in all areas of science. In forensics, with DNA, ultimately, let's just dumb it down to a paternity test. You know, is the tested individual the father of that child, or is it some unknown random person and not the tested individual that is the father of that child, right? So we look at the DNA profiles, and when we do the comparison, we calculate two probabilities. When we evaluate that DNA profile, the probability that the tested man is the father of the child versus, you know, is it not the tested individual, that it's just a random profile in the population that is the father of that child, right? So you have those two competing scenarios, and the number that gets generated supplies weight for one of the two. So if there's equal weight for both, they cancel out and you get a value of 1. So a likelihood ratio value of 1 in forensics means I cannot use the DNA evidence to evaluate which of those two scenarios are more likely to occur. A lot of times that doesn't happen. Usually we say it's in the uninformative range, which means that I cannot use this DNA test to tell you whether that person is the father or is not the father. Okay. A lot of times the lawyers are not too happy with that. But it is what it is. Sometimes the science testing that we do can't give you any type of answer to the question, because that's what it is. I can't make up an answer for you, right? The science is telling me there's equal weight for either. I can't use this DNA testing to tell you that's the father or not. I can't make that determination. If the likelihood ratio value is less than 1, that shows that it supports that it's for the unknown random person in the population and not the tested individual. If the number is greater than 1, then that shows support for the numerator, which is that it is the tested individual is the father. The larger the number, the greater the support. So typically when I testify in the court of law, I'm talking numbers that are in the billions, trillions, quadrillions. And just to test your knowledge, guys, quadrillion is to the 15th power. So a lot of times our spreadsheets say to the 15th power, but juries aren't going to know that. They're not going to understand that. So usually we just have to say it's a very, very large number, right? It's much greater than 1. So typically when I report out a statistic, I'll say that, given the DNA evidence, it is, 10 quadrillion times more likely that Mr. D is the father of the child than if the father of the child is some unknown random man in the population. Therefore, this supports that Mr. D can be included as a father of that child, right? And then I report out, a probability statement that it's 99.99% probability that Mr. D is the father of the child. And then usually they'll get asked at the end, Mr. Benintendo, in your expert opinion, who's the father of the child? And I will say Mr. D. So that's the challenge of statistics. We don't go into the massive amount of math and formulas. I never really got challenged that by defense. Typically, they try to challenge you and ask you, did you really perform the math? Oh, you used a spreadsheet. So didn't the spreadsheet do the math? And I got to remind the jury that, when you perform your taxes, right, did you actually do all the taxes by hand on a legal pad? No, you use TurboTax as a tool in order to perform your taxes, correct? So we use a statistical software to help us do that math as a tool as I perform the statistical analysis, all right? And it's encouraged by our accreditation body, by our rules and regulation, our national rules and regulations, to use a statistical software, because it helps prevent error when we use that software. So that's usually the challenges, the silly challenges that we get. Or they'll challenge you on your expertise in statistics, because maybe my degree says biology and not statistics. So they're like, how can you be an expert in statistics? And they ignore the fact that I've been doing statistical calculations for, over 20 years when you account all my schooling and all the workshops and the classes and all the statistical experiments that I've done in my bio classes that even go back to high school. So they kind of like get into that jargon. So one of the most difficult things about statistics, like I said, is just saying it in terms that the jury would understand without getting, like, I didn't say the word p-value. It's inconsequential to the jury. You're going to be talking way above their heads. So we try to bring it down. So that's what we'll try to do.
I wondered to what extent you talked about cross-examination that you might have from the defense. Do they ask a lot of questions, any questions that kind of go out of their way to try to confuse the jury, kind of to confuse the weight of the evidence that you presented when you talk math with them?
Yes, because we have to be very careful in how we report out a likelihood ratio so that we don't do a fallacy and we don't say it in a way that doesn't make any sense. So they'll try to say, after I say, let's say I test the stain and I test Mr. D and it's a match, and I do a statistical calculation and I report out that given the DNA evidence that it's 100 trillion times more likely that that blood sample originated from Mr. D than if it originated from an unknown sample, right? They may go out and say, oh, so that means, it's 100 times more probable that, Mr. D committed the crime. I'm like, no, that's not what I said, right? So they'll choose words, some type of alternative phrase, because they want to look smart themselves, right? Because remember, they have to put on a show, right? Especially if they're the defense, and it's lock and key, like it's obvious DNA-wise that is their DNA. And, if that semen is in the vaginal cavity of a victim, they can't really deny that, right? Yeah. With the science, they can't disprove that, right? So then they're trying to confuse the jury with wordage. And if I would just say yes to their statement without actively listening, I could do a fallacy. And the next thing you know, they're going to say, you can't believe Mr. Benintendo, he said this, and then he said that, right? So that's one of the key things of traits that I think is good for everybody, is to learn active listening. Especially, it's one of the key things when it comes to testifying. Even when you come to teaching or you're giving a presentation, is to do a good job of actively listening. So even though I've testified 120 times, I get nervous every time. Again, that's that shyness that comes out, but I'm very good at it. And when I'm done with it, because I'm actively listening, my brains are mashed potatoes by the end of it. I can't function after I get off the stand. That's how tired I am, because I have to actively listen to every question that's being asked, because if they change a word, the question is different. So when we testify, we prep with either of the lawyers, whether it be defense or the prosecutor, whoever's putting me on as an expert. Sometimes I do both. So I kind of have an outline of the questions, but even with that, the lawyers like to switch questions, let it be the prosecutor or the defense. They change the order of questions, they'll change a word, and now it's like, all right, my answer is going to be different because they changed a word. So you always have to actively listen to what's being asked to you and what you're saying, because at any point, if I misspeak, I can correct myself, and that's a good thing.
I find it interesting, and I bet some of the AP Stats students in the audience will find this interesting too. They just got done taking an AP Statistics exam where they were challenged to be able to not just report a statistic. In fact, in many questions, those statistics would just be given to them, but they have to be able to interpret what those statistics mean in language, in context. And now to hear you say all this, it kind of justifies how important that skill is in that they use on the AP Stat test. And I just try to imagine what it would be like to be on the stand and have, whether it's defense or prosecution, someone try to wear you down, basically. I mean, as tired as you are, they must probably try to hit at you to get you to make a mistake that way. Is that pretty much what it is?
That's pretty much what it is. And also remember, the statistics that I do, we're using certain frequencies of biological traits that are in that DNA profile. We call them, they're actually represented as numbers. It's not physical traits. So a lot of the data that I use to perform the statistic, I don't have with me when I testify. So it's kind of funny when they ask, can you perform it right now on the stand? And it's like, well, I can't, because I don't have all that data in order to physically do it on the stand. Additionally, it's going to take me at least a day to do all that math and, several legal pads. And that's just wasted time. That's wasted time for the jury. It's wasted time for the criminal justice system. And a lot of times, remember, in that courtroom, the domain, God, so to speak, is the judge. And the judge usually doesn't play with that because it's just a wearing down tactic. It's a distracting tactic. And usually the judge will step in and be like, he obviously did the math. They'll ask, could you do it by hand? Yes, we could. Isn't it more efficient to use the computer? Yes, it is. Was the computer, validated and double checked to make sure that the math that's getting outputted at the end is accurate? And yes, it does. Every year it gets audited. So there's no shenanigans or anything like that. But yeah, a lot of, when it comes to testifying, is that gamemanship to try to trip us up, for us to say a fallacy or to have any type of smidgen to just discredit us. Because again, as an expert witness, I don't have to testify to a fact. Like most witnesses in a court of law are factual witnesses, meaning they can only testify to what they saw, what they smelled, what they heard, what they did, right? As an expert witness, I have education and background in a unique field, and I'm allowed to give my opinion based on that experience and that education, because I have advanced knowledge in a field that a layperson, a typical juror would not. So I have to be very careful that what I say, they're going to believe everything that I say. So I have to be careful to make sure that what I say is backed up by the science and math, not just me pointing and saying, yeah, he did it. No, that doesn't fly, and I would never do that. That's up to the jury to determine whether somebody committed that crime. All I'm saying is Mr. D's DNA is on the ski mask that was left behind at that burglary. That's all I'm saying. I cannot tell you how it got on there. Was the ski mask brought in and deposited? I don't know. Could he have worn it and then left it behind? Because, you know, when you open people's cabinets and drawers, looking in closets, looking for, you know, free stuff, you kind of get overheated and you take that ski mask off. And when you're carrying objects out of value that you want to take, you forget that that ski mask is behind. So it's up to the jury to link all that. All I'm saying is Mr. D's DNA is on that ski mask left behind at that crime scene. So I just link people to objects, objects to people, people to places. That's ultimately what I'm doing with the DNA.
Okay, Matt, as this has been fantastic actually, because I mean you've gotten so deep into some of the math that connects for the AP Stats students, but I'm suspecting that some of our students in the audience right now are also forensic science students, and if that's the case, I definitely want to hit on this before we end up running out of time. Let's suppose you've got somebody who is genuinely interested in not just how cool is forensic science, but actually is interested in possibly pursuing that as a field of study or as a career path. What would you tell a high school student right now who's interested in pursuing that kind of work that you do? What advice would you give them?
Well, it's easier to actually go this career path now than when I did it, 17 years ago. There's a lot more programs out there in colleges and universities all across the United States. I remember in like the tri-state area, or even in the Northeast, your biggest ones were John Jay College and probably University of New Haven. That was pretty much it. There's a lot more options available out there at different price rates. So first thing, I wouldn't choose a school based on how expensive it is. I would choose a school that would give you the best ability financially to come out in the end to be in the better financial status. As it comes to science, I wouldn't double dip. So I see some people that will go into a forensic science program as an undergrad and then follow it with a master's degree in forensic science. I wouldn't do that. I'm also a recruiter for my agency when it comes to DNA testing, and I really don't like to see that. I like to see more people who are diversified. I think you're in a better standing at the end. So if you go to school for forensic science, if you're going to get higher education, choose molecular biology, choose biology, chemistry, statistics, right? Choose something else so that you're more diversified, that you have other options just in case if life has a way of changing, you can change a career more easier, right? So I like people who have a undergraduate in physics, chemistry, biochemistry, biology, and then did that advanced degree in forensic science. Again, you're more diversified. Try to get an internship. We're in the we're in the age where entry level now requires experience. It's weird. It's like the chicken and the egg, right? So one of the easiest ways to gain experience is through an internship or even some type of undergraduate teaching or lab prep at your college or university. It might be simple as cleaning glassware, prepping labs for the teachers and whatnot, but that is technically work, right? I would also try to get any type of volunteer work. We like volunteer work And it doesn't have to be science related. Community volunteer work, or any type of public speaking work would be fantastic, especially if you're a shy kid like myself. Um, Outside of that, I think that's it. Just to try to be diversified.
Okay, that's great. That's a good answer. That applies to a lot of jobs as well. I want to make sure that people know that these interviews are going to continue after this one. They'll be Tuesdays and Thursdays at 12 noon. And our next one is going to be this Thursday at 12 noon. Valerie Rofberg, formerly Valerie Langberg, who graduated Delaware Valley in 2010. She is now a biostatistician with Boston Children's Hospital, what she describes as her dream job. So we're going to be doing an interview with her. Matt, I'm going to try to squeeze in one more question for you, because I noticed that even though Gabby had asked a question before, I am really interested too in hearing what you're going to say to this. So let's pull up that last question here that we'll bring up. And it's, without going into detail, what is or was your most rewarding case? This is going to be fun.
One for you, hard for me. So it depends on your definition of rewarding. There's cases that stick with you that are very tough cases, that some cases don't have an ends, meaning the DNA profile didn't yield anything to the case. Rewarding case, without going into too much detail. So one of the things that I've done for 7 or 8 years is I've used DNA to help identify missing persons. And that could be somebody who was found in an apartment who we think we know who they are, but they're decomposed. So a visual ID can't happen. Or it could be a set of skeletal remains where we have to perform DNA testing. And that might be the only way to identify a decedent. So one of my rewarding cases, I would say, had to deal with that field where had it been about 5 years now, we had something called Missing Persons Day here in New York City. And I interviewed a gentleman who lost his brother. His brother disappeared because both of them were here. They crossed the border into the United States to find work. And their mother had gotten sick down, I believe it was Ecuador. So his older brother, traveled back across the border to Ecuador to take care of that situation. And he tried to cross the border back into the United States, and he disappeared. And it had been probably a year since he phoned his brother, telling him exactly where he was crossing the border back into the United States. So it was kind of difficult, interacting with that person, hearing him tell that story. And I had to take his oral swab, a swab of his mouth, and I performed DNA testing, and I uploaded it into the national database called CODIS. And inside CODIS has DNA profiles of a slew of samples, but for this particular case, we feed in DNA profiles of known people, of relatives of missing persons, like this gentleman, and we also feed in DNA profiles of unidentified human remains. And it took a year, but there was a hit to skeletal remains that were found in the desert in New Mexico. And we followed it up with some additional testing, DNA-wise, and we were able to confirm that this decedent is the biological brother of the individual who I interviewed on Missing Persons Day. So in this particular case, why it was rewarding is because I was able to find closure for this brother. It probably wasn't the thing he was looking for, but he had the understanding, since it was over a year, considering how dangerous it is crossing the border. He was in that impression that his brother probably didn't make it, but he was looking for that closure, and we were able to provide that closure to that family.
Wow. One thing that's really cool about your job is well, part of it's you. You're just so enthusiastic about what you do, which I love. But the other thing is you have so many stories to tell, and you do a really good job of being able to tell just the right amount that you're able to get away with telling. So thank you for that. Matt, you've been a terrific person to speak with today. Matt has been here for years in the past too, coming and talking to our students. So I really appreciate you taking the time off of your work today.
Anytime.
All right. Thank you. Guys, we'll hopefully see you on Thursday this week at 12 noon when we talk with Valerie Rofberg, about her work as a biostatistician. In the meantime, we all use math every day. Have a great day.